using the intermediate value theorem. In some situations, we may know 2 points on a graph, but not the zeros. If those 2 points are on opposite sides of the x-axis, we can confirm that there is a zero between them. Consider a polynomial function f whose graph is smooth and continuous. The intermediate value theorem states that for two numbers a and b in the domain of f, if the number a is less than b, and the output for a does not equal the output of b, then the function f takes on every value between f of a and f of b, meaning the output of a and the output of b. While the theorem is intuitive, the proof is actually quite complicated and require higher mathematics. We can apply this theorem to a special case that is useful in graphing polynomial functions. If a point on the graph of a continuous function f at x equals a lies above the x-axis, and another point x equals b lies below the x-axis, then there must exist a third point between x equals a and x equals b where the graph crosses the x-axis. We call this point c f of c. This means that we are assured that there is a solution c where f of c equals 0, meaning that it is a zero of the polynomial function. In other words, the intermediate value theorem tells us that when a polynomial function changes from a negative value to a positive value, the function must cross the x-axis. Figure 17 shows that there is a zero between a and b. So again, let's take a look at this figure. Okay. So here is the value of a. So we're going to call a 2. Okay. And we can see that there is a value of 3. So that's going to be b. So in this problem, okay, just by looking at the graph, we have f of a has an output. Well, that a represents 2. So what is the output down here? The output is -3. Okay? Now, we now know that we have a value of b, which is equal to 3. So what is f of b on our graph? Well, we know that b is 3. And so if we go up here, we can see that the value at 3 on the graph is 1. Whoops. Okay? So what it's saying here is that we now know that a is 2, and over here b was 3. But what's happening here is that the outputs are changing from a negative to a positive. And so because the output here is negative and the output here is positive, that means in between 2 and 3, it has to cross through the x-axis, which means there's a value that we call c is going to be in between 2 and 3. And that's why they call it the intermediate value theorem. And it only happens when you have an output of a negative that moves to an output of positive. So the definition states for the intermediate value theorem, you let f be a polynomial function. The intermediate value theorem states that if f of a and f of b have opposite signs, then there exists at least one value c between a and b for which f of c is equal to 0.